So we're going to go ahead and take care of the quiz at the end after I go ahead and pass back. But a few things I want to go ahead and take care of. Let me go ahead and give you a quick reminder. Okay, so we are going to go ahead and continue with the sum and difference identities. This is not on your test tomorrow, but you still want to, start committing those new identities to memory. We'll talk about the quiz today. Now, we're not going to finish sum and difference identities until Tuesday of next week. We're actually not going to have a whole lot left, but I did go ahead and provide you the assignment because this is going to be due on Wednesday of next week. So you can at least go ahead and start taking a look at it. In fact, you can probably go ahead and get through number 8, okay, at the very least, based on what we've talked about. So the key is already posted online. This will be due Wednesday, and then we'll have a quiz over sum and difference identities on Thursday of next week. Okay, of course, tomorrow is going to be your exam. So hoping everybody has already or has plans to fill out their 3x5 note card. Okay, good. Maybe you want to put the identities on there, maybe some examples, whatever you think is going to help you. Remember, the material on yesterday's quiz, the simplifying trig identities, that's half your exam. The other half is going to be problems that look like this. This is the previous quiz over the basic trig identities, where you were given the value of a trig function and asked to use that to find the value of another or other trig functions using the identities. Does that remember that quiz? Okay, but that's what your exam tomorrow is going to cover. And then we'll go into next week. We'll keep pushing through. So are there any questions? Okay. Well, what do you say we go ahead and get started? So, sum and difference identities. Okay, so we've already talked about the patterns here. Were there any specific questions about the identities themselves? Okay. Well, let's go ahead. I believe now we've gotten through 4. Let's go ahead and take a look at number 5. So yesterday we did start looking at angles that were radian measures. So we want to go ahead and break this up. Now, just like I said yesterday, if it's a little difficult for you in the beginning to find 2 radian measures that'll add or subtract to give you what you need, I'm perfectly fine with you converting it to a degree measure. I would encourage you, after you find your 2 angles, though, convert it back to radians, work with those. The more you work with the radians, the better off you're going to be. Okay, so let's set this up. So I'm going to use this same denominator here. Okay. So let's say on this one, I want to add my 2 angles together. Now, here's the thing. It doesn't matter what 2 I choose, except they have to simplify to be angles on the unit circle. Like, for example, I need a 13 pi, so why don't I go ahead and say 3 pi plus 10 pi. Okay. So that will definitely give me 13 pi over 12, but what is 3 pi over 12 when it reduces? See, that's pi over 4. Okay, that is definitely an angle that we can work with on the unit circle. And 10 pi over 12, that's 5 pi over 6. There you go. See, that's the only thing. So it can't just be any 2 values that add or subtract. They also have to simplify and work with the unit circle. Now, because of the order I wrote this, pi over 4 is first, so that's my A. 5 pi over 6 is second, so that's going to be my angle B. So for this one, we've already got my identity right there. Okay, so all I need to do is go ahead and plug in. So because A is pi over 4, I'm going to start with tangent of pi over 4 plus tangent B. Well, that's going to be tangent of 5 pi over 6. And this is all divided by 1 minus, and then I want to multiply the 2 together. So tangent of pi over 4 times tangent 5 pi over 6. Now, in order to start the process, we do need to know what tangent of pi over 4 equals and what tangent of 5 pi over 6 equals. So if you're able with a tangent, whether you're adding or subtracting, to get a pi over 4 or a multiple of pi over 4, that is going to make your life so much easier. Okay? Because remember, in a 45-45 triangle, this is when the 2 legs are what? They're the same. They're square root of 2 over 2. So tangent of pi over 4 It's just 1. Does anybody want me to elaborate on that? Okay, let's do it. So let's say I go ahead and run through the whole process of drawing the triangle. So we're going to start with the angle. So pi over 4 is in the first quadrant. Okay. Now remember, once you draw the angle, that's going to become your hypotenuse. I'm going to use that to create a right triangle. Remember, we're going to relate this back to the unit circle. So that hypotenuse is 1. Turn this down. Okay. Now, what I was just mentioning a second ago, what are the two identical leg lengths for the 45, 45? They're both square root of 2 over 2. Okay. Now, remember, tangents ratio is y divided by x. So the y value, square root of 2 over 2, divided by the x, square root of 2 over 2. See, that's why I got the 1. So if you're able to get a pi over 4, it is a very easy angle to work with. Okay. Now for the other one, though, the 5 pi over 6, let's go ahead and work with that. Okay, I'll go ahead and diagram that whole thing. Okay. So let's see here. Let me go ahead and write this over to the side. So tangent of pi over 4, we got that to be 1. Okay, so 5 pi over 6, well, that's going to be in the second quadrant. Okay. Now I'm going to use that angle. Again, I'm going to create a right triangle. Can anybody tell me what this reference angle is right here? Pi over 6. Okay. Now, I'm going to say that this hypotenuse is 1. Again, we're tying it back to the unit circle. Pi over 6, remember, is 30 degrees. Across from 30, that was 1/2. Interesting. Okay. What was across from 60 degrees? What was that fraction? Okay, okay. Close. We don't need the pi, but we do need one more thing. Root 3 over 2. You said 3 pi. That's okay. Yeah, you're good. Now, the only thing to be careful of is, remember what quadrant you're in. In quadrant 2, x is negative. Okay, so now we got to do a little bit of algebra. Remember, y divided by x is tangent. So I'm going to say the y value, 1/2, divided by the x, the negative root 3 over 2. Well, we're going to multiply by the reciprocal. So we got 1/2 times negative 2 over root 3. Okay. Well, those 2's are going to cancel. So it looks like I'm going to get negative 1 over the square root of 3, and we're almost there. Still need to what? Rationalize. So I'm going to multiply by square root of 3 over square root of 3. So it looks like, let me go ahead and get this out of the way. Okay, move this over here. So tangent of 5 pi over 6, it looks like I'm going to end up with a negative root 3 over 3. Is everybody okay with that? Okay. So see, I've got the identity set and ready to go. I just needed to figure out what each individual component was. Okay. So now we're just going to substitute. So everywhere I have tangent of pi over 4, I'm going to go ahead and place it with 1. Everywhere I have tangent of 5 pi over 6 is going to be the negative root 3 over 3. Okay, so let's see what we got here. So that tangent of pi over 4, that's 1. Then I'm going to, it would be adding a negative, so I'm just going to go ahead and subtract that. Root 3 over 3 divided by. And then I've got 1. I want to go ahead and multiply them together. 1 times a negative root 3 over 3. That's a negative root 3 over 3. Okay, but that should be a plus. I'm sorry. Yeah, we were subtracting a negative. Just thinking about that. The answer. Okay, so there we go. Now, don't get me wrong. Here's the thing. That is tangent of 13 pi over 12. That's the answer. That's not the simplified answer that we want. What you're going to find on the tangent problems, they're going to contain more algebra than just the sine or the cosine. Okay, yeah. Oh, okay, because you're absolutely right. Because see, 1 minus, when I go ahead and multiply these together, see the 1 times the negative root 3 over 3, that gave me a negative root 3 over 3. So see, when I subtract in the negative, that is where I got the plus from. Say again? Yeah. Oh, no, 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 no. You got to go through your order of operations. So what you've got down, now I understand what you're asking. So in your denominator, you've got 1 minus. You're absolutely right. The tangent of 4 is 1 times tangent 5 pi over 6, the negative root 3 over 3. So see, this really isn't 1 minus 1 because, see, this is a product. You want to go ahead and multiply that and then perform the difference. Okay. There we go. There we go. That took me a second to realize what you were saying. Okay. All right. Now, we do have a little bit of cleanup to do. There's a couple of ways you can do this. If you go ahead and combine the two numerators, combine the two denominators, make yourself a complex fraction, you can absolutely do that. I think it's going to give you more work. Okay. We want to try to get to our answer as quickly and easily as possible. So the first thing, let's get rid of these fractions. Now, the good news is they both have the same denominator, right? So why don't I go ahead and multiply by 3 over 3? Okay. Now, 3 over 3, what's that value? 1. And what happens if I multiply anything by 1? It stays the same. So see, I'm very careful to make sure that whatever answer I have, I'm not changing its value, I'm just changing the way it looks. So now, if I go ahead and distribute, up in the numerator, this is going to give me 3 minus the square root of 3. See, those 3's are going to cancel. Down below, if I go ahead and distribute that 3, this is going to be 3 plus the square root of 3. So see, it's already looking better than what I had previously. Okay. Now, we have to rationalize it, but the problem is it's not like the previous ones. If I multiply by square root of 3 over square root of 3, it's not going to remove the radical from the denominator. Because we don't have a single term down here, we got a binomial. If you have a binomial in your denominator, you've got to use its conjugate. What am I talking about? Like opposite in what way? Like, what's the conjugate to 3 plus root 3? 3 minus root 3, yes. A plus b, a minus b, 4. So 3 minus root 3, 3 minus root 3. Again, I'm multiplying by a version of 1 because I want to be careful not to change that value. Okay? So I'm going to have to FOIL these together. So let's see what this is going to give me. So first, I'm only focusing on the numerators now. So 3 times 3 is 9. 3 times a negative root 3, that's minus 3 root 3. Inside, that's another minus 3 root 3. And then what's a negative root 3 times a negative root 3? Plus 3. So see, here's mine. First, outside, inside, last. Is everybody okay with what I did? Okay. Now we have like terms. The 9 plus 3 will give me the 12. We do have like terms for these radicals. So negative 3 root 3 minus 3 root 3, that's a minus 6 root 3. Now, down below, we have conjugates. The nice thing about conjugates, if you realize you're multiplying conjugates, your outside and your inside products are always going to be opposites. So this time I'll run through and show you. So let's go FOIL. First, okay, so there's 9. Outside, 3 times a negative root 3, that's a minus 3 root 3. Inside, I get a positive 3 root 3. And then a root 3 times a negative root 3, well, that's just minus 3. Okay, when you're multiplying conjugates, your outside and your insides become opposites. So 9 minus 3, ooh, didn't mean to hit that. That's 6. Is everybody okay? Now we just have to simplify if possible. Like we've seen before, let's break this into two fractions. So this is going to be 12 over 6 minus 6 root 3 over 6. So our final answer should be 2 minus the square root of 3. That's what we're looking for. Okay. So good and bad news when it comes to the tangent problems. Okay, bad news is, yeah, there's a lot more algebra, more steps. Good news, it's nothing we haven't seen before. Okay, if you take it step by step, you're going to be just fine. Okay. How we doing? Yeah, you got you. Okay. All right. Well, let's go ahead and take a look at the next one. Bless you. Okay. So, number 6. So tangent of a negative 7 pi over 12. So I went ahead and previously created another slide so I can have a little more room here. Okay. But I'm going to have you folks direct me on this one. Okay. So I need 2 radian measures. I'm going to go ahead and keep that same denominator. Okay. Let's go ahead and say we subtract on this one. So let's make both of them negative. Okay. So I need 2 numbers that will subtract to give me negative 7 pi, but that will also simplify to angles on the unit circle. Okay, what if I kind of got the wheels going a little bit? What if I started with a minus 3? What would I have to subtract? You know, negative 3 pi minus 4 pi, that's a negative 7 pi. But now look at your angles. Negative 3 pi over 12, that's a negative pi over 4. 4 pi over 12, that's a pi over 3. Those are 2 angles we can work with on the unit circle. Okay. Now remember, order is important. Because the negative pi over 4 is first, that's my A. This is my B. Okay. Now this time we chose to subtract inside of tangent. So let me write out that identity. Tangent of A minus B is equal to, so that would be tangent of A minus tangent of B over 1 plus tangent of A, tangent of B. And we've already identified A and B. So now let's substitute. So this is going to be tangent of a negative pi over 4 minus tangent of pi over 3, all divided by 1 plus tangent of the negative pi over 4 times the tangent of pi over 3. Is everybody okay with what I'm doing? Have I lost anybody? Okay. Now let's start with the easy one. Let's see if we can do this. If I have to diagram it, I will. Okay. But let's see. Tangent of a negative pi over 4. Remember, that's the special triangle where the 2 sides are identical. What should this equal? Should be negative what? Okay. Did anybody want me to show that? Okay, let's take a look. So negative pi over 4, that's going to be in quadrant 4, right? Okay, so here's pi over 4. Again, we're going to use this to create a right triangle. Let's say the hypotenuse is 1. Remember, we've already previously seen that the 2 legs are square root of 2 over 2, square root of 2 over 2. The only thing is y is negative in the 4th quadrant. Okay. So a negative root 2 over 2 divided by a root 2 over 2, that's where I got my negative 1 from. Okay. All right, well now let's go ahead. Let's do the pi over 3. Tangent of pi over 3. So pi over 3 is in the 1st quadrant. Okay. I draw my angle. Use that to create a right triangle. Hypotenuse is 1. Now pi over 3 is 60. What's across from 60? Ooh, not 1/2. Root 3 over 2. Now what's across from 30? That's a 1/2. Right. So now tangent wants y divided by x. So I'm going to take that root 3 over 2 divided by 1/2. Well, this one is even nicer to us than the previous one. Looks like tangent of pi over 3 is just going to be root 3. Everybody okay with what I've got? Okay. Now we can plug in and start our algebra. So everywhere I have a tangent of negative pi over 4, I'm going to replace that with -1. And every tangent of pi over 3, that's going to become a root 3. Okay, now it's just substitution. We're going to replace those. Okay, so I've got a -1 minus the square root of 3 over, then down below, I know it says 1 plus, but remember, -1 times the square root of 3, that's a negative root 3. So I can either say plus the negative, or I'll just go ahead and say minus root 3. And this one continues to be nice to me. I don't have any fractions to deal with. Okay, but I do have to rationalize. And what's that word again? Big word started with a C. Conjugate. What's the conjugate to 1 minus root 3? Okay, I got to multiply by 1 plus root 3. Interesting. Okay. Now, let's go ahead and run through. We got to multiply these together by FOIL. So let's see here. -1 times 1, that's a -1. Minus square root of 3. Minus the square root of 3. And then minus 3. First, outside, inside, last. So it looks like for my numerator, I'm going to get -4 minus 2 root 3. Okay. Now remember, for your denominators, they're conjugates. So I don't have to multiply the outside and the inside terms. I only have to multiply the first. 1 times 1 is 1. And the last. Negative root 3 times root 3, that's a minus 3. So my denominator should be a minus 2. But even if you did the outside and the insides, you're going to find they cancel. Okay, now all we got to do is break it apart and get my answer. So -4 over -2 plus -2 root 3 over -2. So it looks like I'm going to get 2 plus the square root of 3. So you probably start to have a little bit of appreciation for the sine and cosine because those are way faster. Okay? Tangent does have a little more to it. But that's okay. That means more fun. Right? I had my glasses off, but I imagine everybody's shaking their head yes. Let me see, put my glasses back on and see. There we go. Thank you. I appreciate that. Okay. All right. So that is as far as I wanted to go with the notes today. As I said, we will go ahead and wrap this up on Tuesday after your long break. Okay. Will the sum and difference identities be on the test? No. Okay. Let me go ahead and make sure that I am set up for the next class. Okay, now I'm going to go ahead and pass back those quizzes. Okay.